ocean sustainability. The National Academies of Sciences, Engineering, and Medicine seeks to facilitate and develop the scientific community of early career researchers in Latin American and Caribbean countries, as well as the United States and Canada. The goal of this symposium is to enhance the scientific exchange and dialogue among early and mid-career researchers in the Western Hemisphere, and through this interaction, facilitate research collaboration within and beyond the region. This session focuses on oceans under climate change, considering different perspectives, from physical oceanography and climate sciences to the effects on marine biodiversity and socio-ecological systems. We have the honor to have three invited speakers who will share their experiences on these topics and emphasize key ideas, research teams, and strategic actions to support future research on this issue. I'd like to thank the organizers of the symposium in the name of Daniel Plach, Monica Moreno Brush, and Nicola Olibarri, which you kindly moderate this session in loco. As you can see, I was not able to join you, but my thoughts are with you, wishing you a fantastic meeting. I will introduce the panelists. Dr. Tenka Takahashi will start. He works at the Geophysical Institute of Peru, and his speech is entitled El Niño Diversity and Its Prediction in Peru. Dr. Takahashi will bring us a definition of El Niño, its variations and teleconnections, and also approach the effects of El Niño Southern Oscillation on Peru and its prediction shortcomings. He will also bring some strategies to improve predictions on the El Niño Southern Oscillation and its effects on Peru. Our next speaker will be Dr. Priscila Quienteca Lange. Priscila works at the Laboratory of Applications of Environmental Satellites at the Federal University of Rio de Janeiro, Brazil, and integrates the Brazilian National Network for Ocean Observations and Monitoring. Her speech is entitled Response of the Marine Biodiversity to Climate Change. She will present us several aspects of the effects of climate change on marine biodiversity, including biogeographical cycles and temporal distribution of marine ecosystems, and emphasize the importance of healthy marine ecosystems as a fundamental strategy to mitigate climate change. She will introduce the concept of blue carbon and explore in higher detail the effects of acidification, ocean warming, sea level rise, reduction in oxygen level, including other effects of climate changes, as well as the impact of cumulative stressors that act together with climate changes in putting pressure in the natural systems or social ecological systems. In the end, she will bring us a view for the future to think about mitigation and adaptation measures, such as marine protected areas that can be used to face climate changes. Our last speaker is Dr. Melva Treviño. She works in the Department of Fisheries, Animal and Veterinary Science of the College of Environment and Life Sciences in the University of Rhode Island. Melva's speech is entitled Towards More Equitable and Inclusive Ocean-Based Solutions for Climate Mitigation and Adaptation, Centering Communities at the Margins. She will show us how we can learn from communities with deep and long-standing relationships with ocean and marine ecosystems in a way to have inputs to change humanity's relationship with the ocean. She will present us an ethnographic study she conducted in Ecuador, focused on the multi-generational mangrove users' relationships and connections to the ocean and marine resources. So in the end, we will have three complementary speeches that will bring us a wide overview of the nexus between oceans and climate changes. In a way, we will have the opportunity to think about future approaches or developments that we need to have in the region to advance this type of science and improve the way we are doing that in our region. Okay, wish you a fantastic meeting. Bye bye.
Okay, and the other co-chair for this session is Nicola Ulibarri. You have already met her, but I'm going to give you some additional information about Nicola. She is an associate professor of urban planning and public policy at the University of California, Irvine. She is an interdisciplinary scholar who studies environmental policy and governance with a focus on redesigning environmental, regulatory planning, and decision-making processes. So, Nicola, welcome to the stage.
Thank you, everyone. And to be clear, Alex did all of the work organizing this panel. I am simply stepping in as a moderator since he can't be here. So our first speaker is Dr. Ken Takahashi Guevara, who is a Peruvian scientist specializing in climate dynamics, particularly El Nino and its prediction, and then the application of artificial intelligence methods. He holds a PhD in atmospheric sciences from the University of Washington in Seattle and is the director of the Atmosphere and Hydrosphere Sciences Group at the Geophysical Institute of Peru, where he leads the Climate Science Observatory Initiative to make more accessible the results from scientific articles to decision makers and the general public. And with that, welcome, Ken.
Good afternoon. I hope everybody is awake after the big lunch we just had. Hopefully I won't bore you, but before I start my talk, I mean, although the title says El Niño Diversity and its Prediction in Peru, it's not just going to be about that. I'm going to talk a little bit about climate change and how it relates with ENSO. And also, as Nicola just mentioned too, I'm going to talk a little bit about our climate science observatory. So first of all, and let me back up a little bit. I forgot to put a map here, but I guess everybody has a rough idea where Peru is. Peru is in the deep tropics. It's very close to the equatorial line. It's a tropical country, but the ocean is very cold. I mean, it's something. If you go into the beach, you will feel very cold. And that is good for us because this cold water is also very rich in nutrients, and it sustains a very big ecosystem that is also the basis of a very important fisheries that is one of the major exports of Peru. And that is very unusual for the tropics to have cold water, and that is because the winds are blowing in such a way that it's bringing the cold water from the deep, and it's maintaining this surface cool and nutrient-rich. So that's our baseline. But El Nino is when the ocean goes back to what it's supposed to be. So I mean, this is something we've known for a long time. This is a couple of documents from the late 19th century. So this is talking about the one on the left. It's in Spanish because it was written in Peru. It's talking about a warm countercurrent that is going from north to south, from Ecuador into Peru, bringing hot water, probably producing all the severe rainfall we had in that year along the coast. The coast of Peru is normally a desert. It doesn't rain there normally. And that's because of the cold water. But when we have hot water there, a lot of moisture in the air, a lot of heat in the atmosphere, you can get a lot of precipitation as well, and floodings and debris flows, etc. So in this year, 1891, when this document on the left was produced, that phenomenon didn't have a name. It was only a couple of years later that somebody else went there to that region and started asking around, and he figured out that the sailors there already knew this countercurrent, this warm current, and they called it El Niño, or El Niño's current, because it usually appeared after Christmas time, and thus they called it El Niño as the Jesus Christ child, right? So that was thought to be like a common thing that would happen every year, but obviously some years it would be much more extreme than others. So that's how El Niño became a scientific term and went into the literature. Nowadays, people associate with El Niño with climate impacts worldwide. It's supposed to be like this large-scale warming of the equatorial tropical Pacific Ocean that produces effects in the changes in the circulation patterns of the atmosphere everywhere. But the most direct effect of El Niño happens on the northern coast of Peru, as I just mentioned. And I already talked about how El Niño can be associated with very strong precipitation and flooding. So these two graphs here are showing two of the longest records we have of El Niño along the coast of Peru. The one on the top is a river discharge, or one of the rivers up there near the equatorial line. And the one on the bottom is the sea surface temperature measured a little bit to the south of that. And you can see both have a very large variability year to year. These are February through April averages, because this is the warmest and rainy season. So you can see that, for instance, in the top, the Piura River is pretty much most of the time very low discharge. This has very little water, but there's years like 1998 or 83 or 2017 and 1925 in which was huge. I mean, this is in, perhaps the numbers are not telling you much, but the precipitation we had in those events was comparable to the wettest parts of the Amazon. So we go from a desert to Amazon grade precipitation, and this totally changes the climate there. So, and we can see also that the sea surface temperature also follows along, or I would say leads with a similar variability, but there's not a one-to-one relation between the two. For instance, perhaps you all heard that in 2016, so between 2015 and 16, we had a very big El Niño event worldwide, perhaps the third strongest, and that is also seen in the warming along the coast of Peru in the bottom graph. You can see right before 2017 we had a warm event, but if you look at the river discharge there was pretty much no signal. So it was for us it was a dry El Niño. So people in Peru were really confused because we made a forecast. I mean, when I say we're talking about the government science institute. We said, well, it's very likely that it's going to be El Niño, and it was El Niño because the ocean warmed, but it didn't rain. And so people were, well, so what is what, right? This is what actually 2017 looked like along these desert cities. So, and this is a special case because 2017 was not considered a big El Niño worldwide. I just talked about 2016, 15, 16. This was 2017, which for the rest of the world was actually like a cool event. But for us, it was pretty much what a textbook example of an El Niño event. So again, what's going on? So when we look at the maps of how the warming was during those four biggest events I showed in terms of the flooding, we get two different types of El Niño event. We have the ones on the left, which are very well known. This is when pretty much all the equatorial Pacific gets warmer. That's what the red colors show, all along to the coast of Peru. But also, when you look at the right side, we have two types of events in which only the coast of Peru warms. Nowadays, we're starting to call this a coastal El Niño just to make the difference and so people don't get as confused. And we're talking about the global El Niño for the ones on the left, again, so it becomes clear. So when I was talking about El Niño diversity, this is an example of that diversity. We can have very different events, but they have very similar impacts for us. But for the rest of the world, it's different as well. So this has become a source of discussion and confusion even among scientists. Actually, recently, the World Meteorological Organization has been trying to put together a group to figure out how we're going to manage the information about El Nino, because depending to whom you're communicating, I mean, the message has to be different. It's not the same El Nino for the US than El Nino for Peru, for instance. And this makes more explicit how this diversity affects Peru. Because if now you look at the two different warming patterns. So on the top, we have on the left, the warming pattern along the Eastern Pacific, so near the coast of Peru. And on the right-hand side, we have the warming pattern along the Central Pacific. Both could be called El Nino, okay? And it depends who you ask. But if you look now at the maps on the bottom, which are showing how these warmings relate to precipitation changes in Peru, the Eastern Pacific warming produces rain, more rain along the coast. The Central Pacific warming produces drier conditions in the Andes and also the Amazon. So both are El Nino, but have pretty much opposite effects in our country. So obviously, again, this becomes a nightmare to communicate to people. But we have been working on this for years, and we believe people in Peru have started to understand and get used to different messages that are more nuanced in that sense. We're talking now about Eastern Pacific El Nino, Central Pacific El Nino, and we could have El Nino in one region and not in the other, and vice versa, or even the cool phase, which is La Nina. Again, it can become very confusing, but we think people are getting the hang of that. Yeah. Now, in terms of prediction, a big problem for us is that climate models that are the main tool that are used worldwide to predict El Nino are pretty good for the Central Pacific, but not for the Eastern Pacific. And this is an example from the 2017 coastal El Nino event. And on the left, you can see in black what actually happened in the Central Pacific, and the color lines are the predictions made by a bunch of these global models. So these are pretty spot on. I mean, these are good predictions. When you look at the right-hand side plot, which is the Eastern Pacific warming along the coast of Peru and Ecuador, you can see the models just did not see at all that El Nino from happening. So even when they started, when it was already warm, they would say, no, it's not warm, and we'll just keep it cool. So, and this is a problem that we believe stems from biases in the climate models that have pretty much over 30 years that have been known, and that still haven't been fixed. So if you look at the latest generation of climate models, you take the average of the climate they produce and compare it with the actual climate, you will find that pretty much every model is too rainy and too hot along the coast of South America. Pretty much like if El Nino was there every year. But we use these models not to see what the average climate is, but what the variability between year and year could be. So these models are, we believe, because we don't know for sure, that these biases are a big part of why the models are just not doing a good job in predicting El Nino along our coast. So that's why we've been working on trying alternative methods for prediction. One of those is applying machine learning, deep learning specifically, to try to predict the onset of the big El Ninos, the big large-scale El Ninos, not even the coastal events, which are pretty local, but the big events like 1998 or 1983. Because the problem, even when the models are pretty good at predicting the occurrence of El Nino, then the global models are not good at predicting how big those events are going to be and predict it in time. So they tend to predict those events when they're already underway, and you can almost eyeball the trend and see, well, it's happening. So we developed this machine learning model using a kind of a hybrid approach. We took a bunch of simulations from global model for thousands of years and used that to let the model learn about El Nino in this virtual reality. And then we took that model and trained it with more realistic data, which is a shorter term period. And it turned out to be pretty good. It's not perfect. I mean, the simulations at the top are actually independent predictions for the 98 and the 2016 event. The black is the truth, and the light blue shading is what the model range of predictions was. But the really true test is the last year, because we published this paper last year, and the prediction was what we show below that. And what actually happened was this. So again, not perfect, but was quite good. So we're happy with how it's been going, although it's far from perfect. Another thing we've been trying is more complex model, a much more complex model, which simulates the behavior of both the ocean and the atmosphere together, because El Nino depends on that interaction critically. Just last December, we launched this forecast model with the idea that it's going to have less of this bias that the global climate models have. So presumably it's going to be produce better predictions. So this is a line of work we're pushing at our institute. Not just at this point, we just have the ocean atmosphere. We want to complete the other components of the Earth system. And here I'm going to make a parenthesis and switch from the ocean, just for one slide, to the Amazon, because Peru, as Colombia, has both from the coast into the Amazon. And one of the big concerns that we have, even though it's very uncertain at this point, is the possibility that with climate change coupled with deforestation, the occurrence of more wildfires, we will have an abrupt collapse of the Amazon forest, what the people calling a tipping point. So there is a lot of uncertainty about this, and a recent study of the latest simulations, which is shown in these plots, what it's saying is that in certain models, Earth system models that incorporate both the vegetation and the atmosphere all interacting, you can get to a point like in the top of the top plot here, which the forest is growing slowly, and then it collapses. Like it's a 60% reduction in 25 years. Obviously, this is very varied across models. So every model does this differently in different regions, and perhaps even for different reasons. So we're working towards implementing also a regional model that has this vegetation, these dynamics, this interaction, so we can explore and understand better what's going on and how likely this could actually happen. And we're collaborating with the French IPCSL to incorporate the land surface model into our regional model. So that's going back to the ocean and now climate change. Well, climate change is affecting pretty much everything in the world, in particular the ocean. You know, most of the extra energy that the Earth is gaining because of greenhouse gases is going into the ocean. It's being captured by the ocean. And obviously that means that the ocean is heating up. The surface temperature is projected to keep going up, as in the top left plot. But also less well known is that the marine heat waves, which are extreme warm events in the ocean, is also projected to go up. So this means that it's not, when we talk about impacts, it's not just about the average temperature, it's about the hottest days or hottest months. So that is concerning, because the 2017 coastal El Nino event along our coast could be considered a marine heat wave in that sense. So this could also mean that it's going up. On the top right, we also have the acidity of the ocean. That is almost certainly going towards higher acidity because CO2 is just getting dissolved into the water. No mystery there. That's why you look at the width of that uncertainty band, it's pretty much none. But also, and this is a big issue for us in Peru, oxygen in the ocean is going down. And of Peru, we have what we call an oxygen minimum zone, which is below some depth. There's pretty much no oxygen. And if that expands upwards, that means that the fish are going to have less room to live in. So this is something we're also working, and actually in this Earth system model, we're also incorporating the ocean biochemistry to be able to simulate that better. Now, the IPCC report, which is what I was showing in the previous slide, also talks briefly about El Nino. And what they say is that the El Nino Southern Oscillation, which is pretty much this very large-scale phenomenon with global impacts, and it's measured primarily in the Central Pacific, does not show that in the future it could have a substantial change in terms of the temperature variability. However, they find that the precipitation associated with El Nino could become larger. So El Nino produce more rain. The cool phase, which is La Nina, would produce even less rain than before. However, if you look not just in the Central Pacific, but we look at the Eastern Pacific as well, we find that pretty much every climate model that adequately reproduces El Nino indicates an increase in the variability in the sea surface temperature, and that the frequency of occurrence of extreme El Nino events such as 1983 or 1998 could increase, say, by 59% between the 20th and the 21st century. 59% larger frequency. It's a huge number. However, it's difficult to see that frequency when you only have, say, 3 major events in the last 100 years. Particularly, we had in 98, 83, and the previous similar one was in 1878. So it's very low frequency, very few of these events to actually see a trend. What the research is also showing is that the signal of climate change on El Nino, so when we could say, okay, El Nino is becoming more frequent because of climate change, should become more apparent around now, 2030-ish. So this is when the variability of El Nino is going to become higher than what the historical range has shown. And this could be attributed to climate change. So it's probably going to get more obviously worse because of climate change soon. And now I want to talk a little bit again about this issue of science communication, science knowledge. So we currently have a lot of climate science knowledge worldwide, but very few is actually being used. And this is because we have to make an explicit effort to make this information more accessible, the knowledge. So what we're planning on doing, or we're doing actually, is, for instance, to begin with, produce more relevant science. But even if we do not do that, we're trying to identify what is out there that could be useful, to make it more understandable, to make it more accessible, and facilitate the users to use this information. So in essence, what we're doing is this. We're taking a paper, a science paper. We're asking somebody in the scientific community, could be any of you, for instance, that know what is being said here, and translate it specifically in Spanish and in simple language. And we are creating this database of what we're calling interpretations. So this is interpreted climate knowledge from the papers for the user. Currently, we have roughly 400 and so of these interpretations. And it's interesting to notice that the people who are doing this, here it's 172 already that have actively contributed. This is not just us at the Geophysical Institute. It's students, it's researchers in universities, anyone who wants to contribute. Just got to sign up in the top right button in the website, and that's it. And we're also trying to incorporate all sorts of knowledge into this database. Doesn't matter what your specialty is, as long as you can say that it's somewhat connected with climate change. It's very loose criteria. And just to close, so a summary: the diversity of El Nino and its effect of Peru is very complex and has limited predictability. It has counter effects if it's in the Eastern Pacific and in the Central Pacific. We're trying regional Earth system modeling to increase prediction skill, and we're also focusing on the Amazon collapse, forest collapse. So if anybody of you biologists around here who are interested in the forest, wants to collaborate, please talk to me. Artificial intelligence is a very good opportunity because it's very low cost, but it requires that we are very careful of how we develop these models. Otherwise, you could be misleading yourselves and everybody else. And you're all welcome to contribute to our observatory. That's the website, and just sign in or send me an email. Just down there. Thank you.
Thank you very much, Ken. So our next speaker is Priscilla Langer. Dr. Priscilla Langer is a marine biologist whose research focuses on the use of satellites to detect harmful algal blooms and to study the biogeography of the microbiota and their response to climate change around the globe. She holds a PhD in Earth Sciences from the University of Oxford, United Kingdom. She is affiliated with the Laboratory of Applications of Environmental Satellites, or LASA, at the Federal University of Rio de Janeiro, and integrates the Brazilian National Network for Ocean Observations and monitoring harmful algal blooms in Brazil, and projects supported by NOAA to study changes in the Arctic biota using satellites. Here we go. Welcome, Priscilla.
Hello, everyone. I'm a bit nervous because this talk was so amazing, Dr. Takahashi, and tragic. So I'm going to talk a bit about biology in the oceans so you know that it can get worse than that, like even worse. Tragedy is much larger. So there was a little, Alex was telling you what I'm going to talk about, but I won't talk about all those things because there's no time. So I'm going to focus on microbes and the open ocean. I'm sorry, I won't be talking about mangroves or coral reefs because we know more about them than we know about the open ocean. And I think you should know about the open ocean because, as I said, it's more tragic. So I'll start with the statement. The ocean is the planet's largest ecosystem, regulating the climate and providing livelihoods for billions, but its health is in danger. And this danger goes beyond what we can see from the coast. So that's why I'm focusing on the open ocean. And this figure is very nice. It shows, it's a scheme showing the main impacts of climate change in the oceans, like ocean warming, stratification, and sea level rise. And it shows this impacts in the main or some key ecosystems that you can see listed on the top, and also some key ecosystem services. And you can see coral reefs, mangroves, salt marshes, and seagrasses, which really suffer with, especially with warming. And you can also see there the Arctic biota. And in terms of services, we have fisheries, aquaculture, coastal protection, and bivalves, fisheries and aquaculture. And you can't see plankton, which is, well, the basis of the food web. Why? So I'll be talking about that today. So I'll focus this talk on the warming effects in the Arctic biota, fisheries, and plankton. Sorry again, no coral reefs. I had to remove it. So basically, in the open ocean, what happens when you have the warming of the surface is that stratification is created because of the density gradient, and then all the nutrients that are in deep waters and the phytoplankton, the microalgae in the oceans need to grow. These nutrients, they can't come to the surface ocean where the light is available for photosynthesis. So if the surface ocean warms, there's less nutrients, and then you can say that less phytoplankton will grow, but it's not just that, but that's one thing. And it's very clear when we look at chlorophyll signals, for instance, which is a proxy for phytoplankton. So in this scheme, you can have you see on the left hand, normal kind of state of the ocean with slightly warmer surface ocean, then on the right, warmer surface ocean with less phytoplankton and less nutrients. And these images show this very clearly. On the left hand, you have maps of sea surface temperature anomaly. On the top, El Nino situation. On the bottom, La Nina, where the equatorial Pacific is cooler. And then on the right-hand side, you have maps of chlorophyll. And the greener it is, the more chlorophyll. So on the top, El Nino. So you can see the equatorial Pacific is more blue. There's no chlorophyll or low chlorophyll. And on the bottom, La Nina, you have more chlorophyll because the water is colder. That means there's more upwelling, there's more nutrients coming to the surface. So we are looking from satellites at sea surface chlorophyll, but the ocean goes deeper. So it's important to keep this in mind. But that's not the only problem with surface warming in the ocean. The main problem is that the type of phytoplankton that will grow when the water is stratified is different from the type of phytoplankton that will grow when the water is mixed. Basically, if the surface ocean is warm, you have smaller phytoplankton. They are actually as abundant, even in terms of biomass, as it is when you have high chlorophyll at the surface, but they are distributed over the water column, so you can't really see from the surface. But the main problem is that they are small, so small animals will eat them, and then other small animals will eat those, so you have a much longer food chain. And I want you to keep in mind that every time you go from one trophic level to the next, you lose energy. So the longer the food chain is, the more energy you lose, the less fish that we eat you have and other animals eat. So keep that in mind. It's going to be important for the rest of the talk. So because of this general ocean warming, these ecosystems that we call, is this the pointer? Yeah. The ocean gyres, which are these ecosystems, they are very warm at the surface, very stratified. They are increasing in area as well. And small phytoplankton is dominant in these ecosystems, whereas large phytoplankton is dominant in upwellings and other ecosystems like polar oceans. So this increase of ecosystems supported by small cells is bad for fisheries. So that's another problem. One third problem, and to look at this, we need to put one more variable in the equation, which is time. So the ocean is warming, but that also means that when you have seasonal cycles, the water will become warm earlier in the year and it will become colder later in the year. So you have a longer period where the water is warm in most places. So when that happens, because phytoplankton really depends on this dynamics of cold water, warm water, turbulence, stratification, turbulence to grow. And when you have this seasonal shift, what's happening in most areas or most productive areas of the ocean is that phytoplankton blooms are occurring earlier, especially the spring blooms. So I won't talk too much about these plots, but I want you to keep in mind that if phytoplankton blooms are occurring earlier, the animals that will eat these blooms need to be there earlier. And for some animals like copepods, they're just there waiting, so it's fine. But when we start talking about fishes which migrate, then it's a problem because the small fishes may not be there yet when the phytoplankton is blooming. That means that another animal will eat that phytoplankton or zooplankton, or this whole material will sink, which is really bad. And we'll talk about this later. But because of this seasonal shift, there's a lot of ecological disruption in many areas of the ocean. This is just an example of South Africa, so the upwelling of the coast of South Africa, where phytoplankton blooms are occurring earlier and earlier, and then zooplankton is kind of following. Fishes are definitely following, and marine mammals and birds and turtles are not coping, basically. So it's a problem over there. And here we're talking about fish, but what fish, right? That's a problem too. Here is a more specific example of fish. There are two types of fish, a mako shark on the top and a big-eyed tuna on the bottom. And this is the east coast of the US. So these plots on the left show in the y-axis the year, the x-axis the year, the y-axis basically the day of the year when a lot of these fishes can be fished in the ocean, right? So what these plots are showing is that they used to be fished later in the ocean, and now they are being fished earlier in the ocean. So that means phytoplankton blooms are occurring earlier, and they are there earlier. So they're kind of coping, right? But another thing that's happening as well is that these same fishes are being captured more and more to the north, because in the south, this is northern hemisphere. So in the south, it's becoming warmer, and they're just migrating north. So in these maps, you can see the cold colors are earlier years, the warm colors are later years, more recent, and the warm colors are more to the north. So they are being captured more and more to the north every year. This is happening to some species of fish. Other species of fish are just disappearing, right? And that means that the fish culture in terms of consumption is changing. It needs to, because the fish that we used to fish to eat is not there anymore. So we need to eat something else. So this is happening in many areas of the world. And this migration to the poles is also happening in terms of vast ecosystems like mangroves, right? So the mangroves are migrating north, and the seagrass or grasslands, they're migrating north as well, but then they can't go as much. They're collapsing. Kelp forests are kind of collapsing as well. So we have a lot of problems in terms of warming for many ecosystems, including fish. Right, so for some species or some ecosystems even, they can just move north if it gets warmer in the south. But then at some point, there's no north anymore because you're at the pole, right? So what happens? And that's one of the reasons why polar ecosystems are so affected, especially the Arctic. So the Arctic is warming faster. It's surrounded by land. And also the whole ice dynamics there is governed by sea ice, different from the Antarctic ice, which is continental, right? So this is very important. So what's happening in the Arctic is that the ice is melting. So all the algae that grows under the ice is not going to be there anymore. And animals that eat these algae are not there anymore. And then the big, nice, cute animals like polar bears and seals that eat these animals, they starve. So there were some starvation scenes that were very shocking in some years, and that was because there was no sea ice, there was no food, right? Now we know that there is another factor there too, and I'll talk about that a little bit. But basically, if there's no ice, the type of algae changes. It's not the amount of phytoplankton, but the type. Ice algae are like a mat. It's massive biomass concentrated in clumps. And animals that eat that are different, and they grow really fast. When you don't have the ice, you have light in the water column, then the planktonic phytoplankton will grow. And then copepods will be there, and other types of fish will be there. And you have this longer food chain with smaller cells on the bases, and a lot of loss of energy as well through the food chain, right? So for animals that depend on the ice algae or even the ice habitat, like seals and polar bears, really bad that it's warming. So there's a loss of biodiversity, starvation, decline in fishes that are traditionally consumed by locals. And there's another problem, which is the intoxication by harmful algal blooms. And I'll talk about this a little bit now because I work with it. Sorry again. That's the tragedy that I wanted to talk about. So harmful algal blooms, they benefit on warming most species like stratified waters to grow. And in the Arctic, it's a big problem because most of the diet of people in there depend on the ocean. They eat ocean food, right? So if there is a toxic bloom there, it will get to people and it becomes a big public health problem. So Harmful algal blooms can be formed by algae that produce toxins or by algae that don't produce toxins but harm the environment in some way. And we'll talk about this. But in the Arctic, one of the main species that bloom there is Alexandrium catanella, this little guy here. It's ugly. It's a dinoflagellate, and it produces a neurotoxin that causes paralysis. So what does that mean? If an animal filters the water full of these guys and another animal eats this filtering animal, it will be very intoxicated because this toxin accumulates. The good news is that it's metabolized in a couple of days mostly. So if a bear is intoxicated, it will have a little, starve for 2 days and then it's going to be fine. But if a bird is intoxicated, it will die because it's so tiny, it needs to eat all the time. So there's a lot of massive deaths of fishes and birds because of these toxins in the Arctic and elsewhere, in Chile as well. We've seen a lot of those things happening in Brazil too. And it's a major problem in the whole world, not only in the Arctic. So good thing is that when these cells are in the water, they change the color of the water. So we can see it from satellite. This is just an example of an image. This is the Bering Strait. And there's a bloom here. You can see the water is kind of red. This is enhanced color. It's not as red, right? But then we can just use color to create models and estimate the abundance of these harmful algae and at least have a sense of where they are, which is great. And we can do it anywhere. But these blooms occur especially in coastal areas everywhere in the world. This is another example of a bloom in Rio in 21. This was another dinoflagellate, not toxic. And it may not be a problem if the bloom is there and then if it's diluted somehow, but it may become a problem when these blooms become so vast. They occupy like this huge areas of the ocean. So this is Rio here. This is south of Brazil. Uruguay is around here already, right? So this is a massive bloom. And it just started in that one, okay, that occurred in Rio. So it may become a big problem. And again, this was not a toxic bloom, but the problem is what happens when these blooms die because animals are not eating it. So I'll just play this video, hopefully. So what you see here is just a massive amount of dead biomass of one of these blooms in Rio. This is the surface ocean. It's not mud, okay? So the boat is sailing, and I'm showing this just so you have an idea of what happens to this biomass. It's dead. It's being decomposed by bacteria that respire oxygen. So what happens after this is hypoxia and fish kills, right? So it's a big problem. And this is going to sink, and this will go on in deeper waters. And you have this increase, even bigger increase in oxygen minimum zones. So it may be a big problem if it increases more and more with the ocean warming. Okay, next. Okay, so to summarize, the effects of the warming surface ocean, it leads to ocean stratification worldwide, and this stratification leads to change in phytoplankton size and species, change in herbivore species, and change in ecosystem structure, creating longer food chains, and then it ends up in loss of living energy, basically. Similarly, there is a change in phytoplankton phenology or seasonality, a shift in fauna phenology or starvation of some species, and species migration poleward. The warming also leads to ice melt in polar regions, which leads to loss of habitat and starvation, and also changes ecosystem structure. And finally, warming favors harmful algal blooms, which will lead to food intoxication, oxygen depletion, and change in ecosystem structure. And I'm just talking about the open ocean. it gets worse in the coast. So this is just a summary of all the problems that climate change are driving in the oceans, and we only talked about the ones that are marked in red. So yeah, sorry. I really wanted to talk about possible solutions for that. I honestly don't see one right now because we can't really change warming at this point or the effects of warming in the ocean. But if you have any ideas, please share with us. Thank you.
Okay, thank you. And our third speaker is Dr. Melba Treviño Peña, who is an assistant professor of sustainable food systems in the Fisheries, Animal, and Veterinary Sciences Department at the University of Rhode Island. She's a coastal human geographer and an ethnographer. Her broad interests concern studying how intersecting identities like gender, race, ethnicity, age, class, etc., inform people's perception of the environment and their responses to environmental change. She holds a PhD in geography from the College of Earth, Ocean, and Atmospheric Sciences from Oregon State University. Right. Welcome.
All right, I was falling asleep earlier and I drank a lot of coffee and now I'm jittery, but I'll do my best. So today I will be talking to you about, there's a lot of ideas out there about ocean-based solutions. We hear a lot of blue economy language out there. And oftentimes in these conversations, aspects of equity and inclusion are not really part of the conversation. So one way that I propose that this could be better addressed is if we really start to talk to the communities that are facing these impacts already. So centering communities that are at the margins. So today I will be talking about mangroves, Priscilla, from a very different place, but mangroves are here. And yeah, I'll move on. So first I'll say I'm going to share stories about a community, and it's very broad community, but I also want to point out that even within communities, there are different people that based on their gender or age or education level, class, they face environmental change differently. So I just wanted to point that out. And starting with this quote from Vera says, sorry, the text got messed up, but and it says, poverty in mangrove communities has the face of a woman, and it's a conchera. A conchera is a mangrove cockle collector or gatherer. So I'll be talking a lot about them today. So just wanted to start out centering them. And I'm pretty sure a lot of people know what mangroves are. I just thought I'd leave this slide here just in case. One of the things that I do want to point out is that mangroves provide a lot of ecosystem services. There's one of the most productive forests in the world. And specifically in more recent decades, they've been giving a lot of importance because of their carbon sequestration capacity. So and more when we talk about climate-based solutions, mangroves are really a part of the conversation, whereas just a few decades ago, they were considered wastelands. Not much could be happening there. So again, just to provide some context and where I come into this conversation is some of the blind spots in blue ecosystem assessments. So with the blue economy language, is anybody who works in ocean anything hears all about the blue economy, and it's been presented as a tool for helping make informed decisions, right? And oftentimes, though, it doesn't really, these types of assessments don't really provide a holistic view of ecosystems. So some of the areas that I'm really interested in as an ethnographer is, for example, cultural ecosystem services. So sometimes you might think, well, you know, some of that cultural aspect or non-material dimensions of ecosystems are incorporated in fisheries or tourism. But for example, when it comes to tourism, that's really still based on outsiders and not necessarily the communities and their perspectives. So just kind of like, there's a lot. I'm trying to just present a big story here. But more recently also, we have now, we are in the decade of ocean science and sustainable development. And there's really beautiful language in these reports. But one of the things that I was wondering about is, you know, it talks about this idea of like They want to identify transformative ocean science solutions for sustainable development and connecting people to our ocean. But my questions are, like, what about people whose lives are already very intertwined with the ocean? And what can we learn from communities that have really long-standing, multi-generational relationships with ocean and marine ecosystems? So that's the story that I'm telling today based on my ethnographic work. So the stories come from Ecuador. Continental Ecuador has 5 mangrove regions, and each region has communities that are culturally very different from one another. But at the same time, as a collective in the country, they've taken this name where they call themselves the ancestral peoples of the mangrove ecosystem. So the specific community I'll be talking about, I'll show you a map in a minute, is a community in northern Ecuador. So I just wanted to put this out here. If you have questions, we can chat more about the methods. But essentially, I am an ethnographer. I rely a lot on talking to people and qualitative research. Very unapologetically, I love it. So I can share more about these methods, but I just wanted to show you kind of geographically where am I talking about. So this is a community that's very representative of a lot of coastal communities in Ecuador, where they're rural for the most part. And there's in some of the more rural communities, there's not a lot of livelihood diversity. So a lot of people really rely on whatever jobs they can get. So here I just have a representation of some of the jobs, like small scale agriculture, very, very small scale fisheries, a little bit of tourism, construction, and a lot of women, for example, cooking food. But in this community in particular, like in a lot of mangrove communities in Ecuador, a lot of the communities really rely on conchas or mangrove cockles. And they were, until the 1980s, they didn't have a lot of commercial value. Before that, they had a lot of value for communities. But as they started to gain commercial value, it became a source of livelihood. So the people who gather cockles are called concheras or concheros. And here's just some photos again of what this job looks like for people. So there's a lot that I could talk about, like the relationships here, but I wanted to just highlight some of the ways in which, yes, this is a source of livelihood, but beyond that, mangroves for these communities are more than what we think of, ecosystem service providers. So the first thing I'll say is that this practice is a multi-generational cultural activity that historically was practiced by women. And it had the knowledge of how to do this practice was passed down by women. So a lot of the children would go with a mom or grandmother or aunt, and this is how they learned how to engage in this practice. However, like I said, in more recent decades, it went from a subsistence practice to a livelihood practice. People talk about how it's access to plata caliente or like hot cash, like cash in your pocket. So it's really just, if you need money, you can go to the mangroves, you're gonna have money. So this is especially important for women. I'll mention this later, but women have not had access to wage labor. So this practice allowed them to be able to make some money. So here's just some of the quotes, like this woman saying that her grandma and her mom tell her that this is how they maintain their families through the mangroves. So mangroves provide access to both informal and formal education. A lot of these kids that go from a very young age, sometimes as early as like 2-3 years old, which is crazy because I have a 2.5-year-old and I could never imagine taking him in this space, but they've been going from very early on. So they really learn a lot about the mangroves from going with their family members. But also outside of informal education, they also provide access to education in general. A lot of the people talked about how through this money, they're able to pay for their schooling of their children. And for women, that's very important. And they feel very proud that they're able to do that. But also sometimes the kids, they go for fun. But even though they're doing it for fun, they collect these cockles and they're able to give them to their parents who then commercialize them. And then in turn, they're providing a source of income for the family. Women, again, there's so much and the gender dimension is very big here, so I'm just trying to put it into a couple of slides. But in reality, it does mean something different to the women because of that source of economic independence. So like, for example, there's women who talked about being in abusive relationships and they were able to leave a partner who was being abusive to them because now they have a source of income. So it's, again, there's so much importance that women have tied to the mangrove But in general, it also supports just their well-being, including mental health. So a lot of women talked about how they don't have any time to socialize, but when they go to the mangroves, they're able to socialize, but at the same time, they're also working, so they're not wasting their time, because God forbid they have fun. But this is a really important thing for women. So in this quote I have here, this woman was saying that sometimes she's very stressed and she goes to the conchas, that's what they call it, going to the mangroves, or las conchas, and there's so much tranquility and this air just brings her back to life. So not just for women, but in general, the community, there's a big sense of pride as to what the mangrove ecosystem means to them. So here's just some quotes reflecting that. The first one was actually by a man who said that the mangrove has given so much to the community, and they all recognize that this is like an honor that they have. And he said it's like a national flag for them. The women, it gives them an identity outside of being like a housewife or a mother. They also can say, I'm a conchera, and that's really important to them. And this other woman who actually had retired from the practice due to old age said that even though she no longer was going, she still remembers and she sees those mangroves, and it reminds her of how important she is, because those mangroves gave her that identity to be able to call herself a conchera, allowing her to shine as a conchera. So this is a poem which I don't find myself particularly artistic, but I created this found poem based on all my interviews. So this is text that I gathered from my interviews to create this, and I feel like it really holistically represents what the mangrove represents for people. So I'll read it to you all. So the mangrove represents our life and that of our children, of the future we have in front of us. The mangrove has life. It gives you strength and energy. We return that life with care. We enter it with love, because love is what makes us take care of things. In the mangrove, I feel like I'm at home. I come in as I go, as I enter and leave my house. I feel such tranquility there. It's where I feel free. That's why the mangrove is my life, my everything. The moment we enter it, it's like finding our mother. You can go carrying all these problems, and the mangrove hugs you. It takes away your hunger and thirst. It takes away your anxiety. Because we see the immensity of the mangrove, we have faith and certainty that it will help us resolve the problems we're carrying with us. In the mangrove, I see my father, my mother, my family, my ancestors. I will always be a part of the mangrove. So you can see that this is really a deep relationship that people have with this ecosystem. And they feel like it's very important to them, as you can imagine. So switching gears to conservation efforts, this is actually a reforestation day. This is an abandoned shrimp pond. I'll talk about shrimp farming in a minute. And I want to just capture some of the conservation efforts that have been taking place in this part of Ecuador. So mangrove forests, again, they're very important for carbon sequestration, but they're also some of the most threatened tropical ecosystems. So global decline for mangroves, it's estimated to be from anywhere from 30 to 50%, but realistically, it's probably higher now. It's a bit of an older statistic. But there's a lot of pressures that are leading to mangrove deforestation, coastal development, economic activities. But one of the largest drivers of mangrove loss is aquaculture, industrial aquaculture. And specifically, something like 38% or something like that can be attributed to shrimp farming alone. So here's just some pictures of shrimp ponds when you're entering the community. They're surrounded by them. So this is just a brief image from Google Earth, and you can see the town is very small. It's about 550 people, and the footprint of the town is almost as big as some of the shrimp ponds. That's how big the shrimp ponds are. This is just the southern part of the Muisne River estuary. This is, again, in southern Esmeraldas, and it's estimated that mangrove decline in this estuary dropped about 87%. So quite dramatically. And all of this land cover changes for these little shrimp that are actually not consumed by the community. They are for export. So there's a really kind of crazy history with mangrove conservation in Ecuador. But to just kind of get you to the point that I need you to be at, is that in 1999 at the country level, they allowed communities to be able to apply for mangrove concessions. So until this time, specifically in my field site, in the 80s is when shrimp aquaculture was introduced. And a few years later, people started to fight back. They were really upset about the deforestation that was happening. They saw how it was affecting their lives, but there was not much they could do about it until 1999, when suddenly communities could apply for mangrove concessions, and then they could establish what what that use would look like. So in the context of the mangrove river estuary, for example, different communities and groups of fisherfolk associations, like concheras associations, mostly they were women at the time, they were the ones that were the custodians of these spaces. And what they established was these types of extractive reserves where the mangroves were protected, but it also guaranteed their access to their spaces. So when I ask people like, well, what is your function in the ecosystem? Or do you consider yourself a part of it? They would say yes. And I would ask, what's your function? Predominantly people would say to take care of it. So here's just some of the examples of the actions that people take to take care of mangroves, like stopping deforestation by reporting illegal logging, for example, or talking to the shrimp farmers and convincing them to do things in sustainable ways or in more mangrove-friendly practices. They also talked about like educating other people. In the past, especially, they employed rotation systems, but as there's less and less mangroves, it becomes harder to establish good rotation systems of where they gather cockles. People talked about not taking small cockles when they can, keeping them trash-free, but especially they talked about deforesting degraded areas. So a lot of the women talked about how in the 90s, they began to reforest mangroves, and how the men thought they were crazy. And people were like, I've never heard of this. This is like the stupidest idea. But then when they saw that it worked, all the men were like, wow, this works. So they started to see that if they could reforest them, mangroves could come back. So in 2014, again, there's a lot of history with mangrove conservation in Ecuador, but in 2014, something specifically happened, which is that there was introduction of a conservation project called Socio Manglar. It's a partner, the partner mangrove partner, and it's based on this bigger project that had been established for some time called Socio Bosque. And there's this idea that you can create partnerships for conservation, and I really do like their logo because it's like you're partnering with nature, right? So the biggest things that the plan would entail is restricting the expansion of industrial activities, but it really was focused on educating the public, providing economic incentives, and limiting access to the mangroves. So as you can maybe imagine, that became problematic. So this is not my photo, but this is just a photo I found from a newspaper where this is the first recipients of incentives from the Socio Manglar project in the southern part of Ecuador, where it was first introduced in 2014 again. So it was presented as this win-win, everybody wins strategy where you're now able to have access for conservation projects that historically have not had access funding for, such as mangroves, that are historically were very little funded in Latin America, but especially in Ecuador. So it became this really effective climate mitigation strategy. It's very much based on the RED model. If people know about reducing emissions through, through deforestation and degradation, yes. So again, based on this bigger model of providing incentives, the idea is people will care about conservation of forests if we provide them incentives to care for them. So they really this project in particular was really focused again on engaging in partnerships with the communities. The government would create these partnerships, then the communities would take care of the mangroves. And they also said that there'd be a lot of other alternative benefits, such as alternative livelihoods, ecotourism, and basically was presented as a really good strategy. But in many communities, there was actually huge opposition to Socio Manglar. So in this picture, you can see this is a shirt that the conchera was wearing, where in their mind, they're comparing mining, something so destructive like mining, to this conservation project. So they said that the reason they were against it is because they really didn't see this as a local benefit. They saw this, that it was going to exclude people from the mangroves. And the really biggest problem is, in particular in the place where I did my work, is there was a conchera association. That's who the government approached for this partnership. They needed an organized group. When they said no, literally the next week, there was a new group that said, we're also an association, we're gonna make one. And anyway, it was mostly led by men. But it really created a lot of division in the community, and there was, like, to some points, there was almost conflict happening where people were physically fighting and hitting each other because of these conflicts. So the problem with a lot of these top-down projects is that they really don't pay attention to what communities want, what they need, and what they have to say. So here's just some examples of how the community's perspectives have been erased. So first of all, again, I'm just trying to introduce, there's a lot more I could say, just don't have time, but people have taken care of the mangroves and they feel very proud of that. For a while they didn't. They allowed the shrimp farmers to come in, but now they have. And now their efforts have been erased. It's as if no one's ever done anything. And people also talked about they don't want a privatized mangrove, they said. They want a free mangrove. This person was talking about how they recognize this as a benefit, so they want they said, we ourselves should be the ones to take care of it. This other one gets deeper at that. It says, I wouldn't like if someone else, specifically they said an outsider, came to protect them because we wouldn't be a part of the mangrove anymore. So there's this idea that if you come in and you start taking care of my mangrove, now I'm no longer a part of it. That's how they saw it. And people said about, we should just be conscious that we need to take care of this ecosystem without being paid. People talked about how they would do it for free. They've been doing this for a long time. People talked about it gives them life. And I'm going to run out of time. So anyway, someone said about why should we be paid to take care of the mangroves? And this person was saying that when they came and told them about this project, they're like, why are you going to pay us? What are you really wanting out of this partnership? So what I'm trying to show here is that there was historically, there was a relationship people had with this ecosystem. When you bring in a project that provides incentives, it starts to change that relationship. It's no longer about that connection that people have. Now it starts to be driven by money. So just to summarize a lot of this, again, sorry. I want to do it. It's just meant to be a conversation starter. But now to kind of wrap it up and bring it back to this idea of how do we create more equitable and inclusive practices. So a lot of these ecosystem assessments, again, I'm not saying that they're bad. I just think that they are not holistic. And I think that qualitative research can provide sometimes insight into those blind spots that these ecosystem assessments are not able to grasp. I think that we need to create not just multi-disciplinary approaches, but inter and transdisciplinary approaches. And we really everyone can do everything. You cannot have multiple PhDs in multiple fields so that you can do these projects on your own. I think it's really important that we rely on collaborations, and not only with academics, but it's really important that we figure out ways to engage in collaborations with the communities themselves. So I loved your idea of presenting research to people. And I come from a place where there's a lot of science communication is a really big part of the training I've gotten, but we also need to listen to what communities are telling us. So our job is to talk to them, but part of talking also should be listening. So the local community members are they're ecosystem beneficiaries. They need to be a part of these conversations. They also have a lot of knowledge. They may not use the language that we use, but it doesn't mean that they don't know what they're talking about. We need to bring them in and respect them as equal knowledge holders, just like we are. And we need to understand really why these relationships exist and why people think the way that they do. Because when we ignore these types of narratives, we could create really poor unintended consequences for people. For example, when shrimp farming came, I don't think anyone thought that it would lead to maybe higher rates of domestic violence, but it has. So, we're not thinking about these things. We need to understand how these ecosystems provide benefits for communities so that we can make better decisions. And the last thing I'll say is, I think it's important that when we engage in these conversations, we really think about what is being included, what is do an inventory of what is actually being included so that we can see what is not. I also think it's important to think about who is being included, and not only who is being included, but how are they being included. In this project, they were presenting it as a community partnership, but the community needs and their voices were not actually being heard. They were there for the pictures, they were a checkbox, but they haven't historically been actually heard. So it is really important that we think about, these communities are at the front lines of climate change. They're the ones that are going to be bearing the impacts before any of us do. So how do we actually show up, provide them access to resources and information, and empower them so that they can protect themselves? And it doesn't result in bigger problems down the line. So that's it, and thank you.
Thank you. And we now have time for some questions.
Thank you. Thank you for your presentations. For the Dr. Ken, what do you think? What do you think ENSO is so difficult to forecast, and what do you think we need to make a good forecast? Is it any suggestions, alternative?
Yes, thank you for the question. Actually, I think the first thing we need to figure out is what we need to be forecasted. So what I was talking about, even though we could say that generally we have an adequate ENSO forecast, so El Niño Southern Oscillation, this global Niño, because the climate models worldwide are pretty good. For us in Peru, it's not enough. So if we don't know that, we will not be able to demand or suggest or at least attempt ourselves to improve those forecasts, right? So other countries in the region actually use directly the information from NOAA in the United States, and that was apparently pretty good enough for them as far as they knew. But then when these new types of events happened and things didn't go as they expected, then they started also to figure out that perhaps it's not enough what the US was producing, because, I mean, I'm not going against the US, but actually the US puts out a lot of information. So it's very, very good in that sense, but it's not meant for everybody. It's meant for the US. So every country has to figure out what their needs are in terms of climate information and forecasts, and then figure out a way of getting that to be as good as possible. So now we're talking about the actual, from the physical perspective, the Eastern Pacific is particularly difficult to simulate by climate models. It has a lot of processes going on that are local scale, and that are apparently, for some unknown reasons at this point, very difficult to simulate in the models. So it's not that scientists haven't tried, they just haven't made any real progress in the last 30 years.
Hi, I'm here. Thank you all for the talks. Were great, all of them, and they were very different. So I actually have questions for the three of you, but I'm gonna pick one for Melba. I was very interested in your qualitative research using, people testimonies, and my question would be, how do you? I'm not very used to this kind of data. Maybe like many of us come from more quantitative data, and how do you close the gap between qualitative research and quantitative research? So how can you use this information to to incorporate it with, I don't know, models about how these mangroves or any ecosystems develop to integrate this information? I don't know. This is a very general question. It's not my field, but I was very curious about your talk. Thank you.
Okay. That's a question that a lot of natural scientists ask, and it's really hard because the data and the way that you would collect the data is so different. And I actually teach ethnography to graduate students that come from natural scientists, and every day in class they're like, but how? Like, they just don't see it. I'm like, just trust the process, just wait. The truth is, I think it's really hard to integrate these type of data. For example, using Ken as an example, even your research, it's really hard. And I don't think we should always be thinking about how are we going to merge them, but potentially it's like, what are you showing in your stories, and where are the gaps that my data can provide into those gaps? And my story is not going to tell that story. So I think rather than thinking about, I think it's really hard to, sometimes people try to merge qualitative and quantitative data and it just becomes a mess. It's really, really hard. But maybe rather thinking of like how to merge it, we should be thinking about how to complement one another. And I think that qualitative research can be a really powerful way to show gaps that quantitative researchers can show, and vice versa. We can't show that data because it's so different. So my suggestion is that we should be thinking about what are we telling with these stories, even though mine is clearly a story, yours is also a story, yours is a story. So we need to think about like how to integrate these stories, knowing that sometimes they're not going to be matching perfectly with each other and being comfortable with that. I think in science, that's like, especially qualitative research is so in the gray zone, and it's so, it makes people uncomfortable because they can't say with certainty this happened, you know? So that's a good question, but yeah, I hear it a lot. And I think, again, it's just about being okay with them not being perfectly a match, but recognizing that they each have strengths.
Thank you very much.
Hi, thanks for all the talks. They were really, really interesting, sometimes saddening. And that's a bit of where my question is going towards. I work a lot with trying to use knowledge to influence policy, and especially in Ken and Priscilla's talks, my question is, how are you connecting the knowledge that's being generated and try to bring it to people who have the power to make the decisions, maybe not to stop it because there's no stopping it, but to adapt and move people and create interventions, etc. Yeah, so how are you doing that? And what would your recommendations be to other people who are doing this kind of science? And also, how do you keep hope alive?
Great question, especially about the hope. Yeah, my talk is really depressive, right? But I'm actually really hopeful, especially when I talk to communities that live by the ocean. So I do work with some communities, basically fishermen communities in Rio. And it's funny because I go there to do like environmental education. And to be honest, I go there to ask them, so what's happening? What should I measure? So that's one thing. They have a lot of qualitative data in their minds, in their lives, you know. And I ask them a lot about these kind of information because it gives me a lead of what to measure, what to transform into numbers so we can analyze that. So they really help me much more than I do help them. But then when it comes to decision making, then you need skilled people in communication. And we have a big problem because scientists are mostly not trained to communicate. And I think this is a gap in education, really. And I always say that it's terrible. It's a niche. It's not occupied, and it should be. It's really important. But what we try to do is try to bring the local community, scientists and decision makers together. They are very busy, so they don't have much time. So you have to synthesize everything. It's difficult. But at the same time, when it becomes a social problem, which often happens in coastal communities, it's easier to tackle them. It's like, oh, it's a problem. So you're losing money. It's going to be in the news. And then they start to be worried. And so we talk, right? And so they try to find ways to help. And when it comes to finding solutions, I really think the ones that really know what to do and what problems to solve are the ones suffering, which are the local communities. So in the end, scientists try to measure things and prove them just to make this communication between the local communities and the decision makers. That's where we are with numbers. So it's like, oh, you're just saying that. No, I have numbers to prove it. Okay, keep going. So we're there. I think we have a lot to learn. So in terms of advice, my advice is open your minds and try to learn as much as you can from local communities and from decision makers as well, because the world is not heaven. It's hard to be a decision maker as well. So you need to learn from both sides and become like this person that does everything, a little bit of everything. We have to be, you know, because otherwise you don't understand demands of the local communities and of the stakeholders. So it's really complex. I didn't answer any of your questions, but that's where my mind is right now.
If I may just follow up on the question. So my position is different because I'm a public servant. So I'm at a government lab that is directly under the Ministry of Environment. And the ministry is our main partner in this observatory I was talking about. We actually got them to pay some money for it. So they've already bought in. But still, it's a challenge even with them to be able to communicate. We recently, last week, had a meeting which was a little rough in that sense because our goals are not necessarily are the same. But that is the good thing is we're talking about that. And the next step is how to get, say, all this information we're creating to the users, starting, say, going from the national at least to the regional, because Peru is divided into 25 regions. So we need to now talk with the regional authorities so that the scientific evidence is incorporated into their local original plans or the climate change strategies, which they are in the process of updating. So we need to, we're, again, talking with the ministry to have them help us get into those processes so that we can provide technical assistance to the local governments or regional governments. No, it's not just that here's the website, just use it. We need to be able to communicate, to work with them so that they know what we're producing and we figure out what they need from us. So that's still an ongoing process. We don't have it figured out totally yet, but hopefully we'll have some success that we can report on the next meeting.
Hello, David Bernal from Purdue University and NASA. I joined the sentiment. It was a very interesting session, a little bit sad. I'm leave this session worried. I also joined the sentiment. There are many questions. A short one, just for the matter of time, for Ken. In your science communication project, where you are engaging scientists in summarizing and basically distilling information from papers for a broader community, have you considered using, this is where I'm coming from, using generative AI for this? Literally, it tends to be very useful in summarizing this. Obviously, there needs to be a scientist in the loop, but you using artificial intelligence, using this to summarize papers and make them more accessible to communities, as we were saying before, is this something that you have tried?
Yes, we've tried.
How did that go?
No, so when we started with this initiative, it was in November 2022, just before ChatGPT was launched. So our idea was human intelligence. So I have this large community to contribute with all this work. Now, earlier last year, we started implementing an application using large language model to try to mimic what the humans are doing, and also to take the summaries that people are producing and creating reports that are more easier to read than just like these like items, which was good but not great because sometimes it really messed up. So sometimes the models would produce what we call hallucinations and make up information was not even in the original data or information we're providing. So we're giving it to them and saying, just summarize this. It's not like asking a broad question and ask it to create all the content. We're actually giving it to them. So we're still working on trying to improve on that model. New models are being launched with even more capabilities, a better accuracy, fewer hallucinations, even much bigger what they call the context windows. So we can provide all the data with more information, and perhaps eventually it can replace the humans. But at this point, we're going to be using it as a second grade complement to what the humans are producing, just like an aid rather than a substitution.
So on the subject of science communication, which seems to be kind of a overbranching subject here, say the products that Ken you're producing, or when Priscilla and Melva communicate with people, do you see, do we need to communicate differently when you're producing, say, papers, but hey, would you have a report to like policymakers, which seems like that's what Ken was kind of producing, versus targeting like local communities? So can you comment, the three of you, on how to, when you're doing science communication, how to target one versus the other? What are the challenges, difficulties, the strategies?
Yeah, I think, yeah, it would be a very different kind of report. It might not even be written, right? Depending on the community you work with. I'm sure, like, if you're working with fishers, like, you don't want to show up here, read this report, let's chat about it. Like, that's not how it would go. I've been doing a lot of work with community-based organizations in Rhode Island, and to me, that those types of organizations that have connections with the communities, like, I don't belong to those communities, and it would take a long time for me to build that relationship with them. So what I'm finding to be a really good strategy is to find community organizations, like community-based organizations, NGOs that are working already with these groups, that have trust. Because when I show up, they kind of already trust me because I showed up with the person that they trust. So I think that if you're talking to the public, depending on who the public is, that's also so broad. But, like, even with, like, I work a lot with immigrants in Rhode Island. Like, I'm not going to show up with a written report in English or even in Spanish. I think we need to show up and to have conversations that are very informal. You kind of need to understand the cultural context that they operate in. So, and you need to, it's a lot of work, but you need to figure out how to operate in that cultural context as much as you can so that you are accessible to them. If you show up to a policymaker or even like the youth, you could show up with maybe more formal written things, but it just depends on asking. And I think if you don't know, the best thing is to ask people who belong to those communities, like, how do we talk about this? And like I said, for me, community-based organizations, they are a bridge to accessing the communities that I want to work with. And that has been really effective. And I just think it's the best way to go about it, because they can tell me, like, don't talk like that, don't say this, don't say that, this is how you approach it. So it's like they're like they're my shortcut to getting to the community. So I think those partnerships are really important. But you mentioned we're not trained to do that. A lot of times we're not even trained to be thinking outside the box. Who do I engage with? When you approach these people, how do you present yourself? Like, if you are not careful, you could come off as arrogant, you could come off as hot-headed, and they don't want to talk to you anymore. So it's like I think we need to be having more trainings with students, with ourselves, so that we can share with each other, like, how to do the best practices. And everything we learned in academia basically just doesn't work when it comes to working with people.
Yeah, I think in my perspective, when you talk to stakeholders, you have to talk about problems and solutions, be very clear and short. This is the problem. This is what we need to get to this solution. Then it makes their life easier. It's less decisions that they have to make, so that helps. And when it comes to the broad public, it really depends on who you're talking to. But for local communities, at least in my experience, I feel like if they feel like they are helping because they want to have their lives improved and their environment improved. So if they feel like they are helpful to, I don't know, improve the mangroves or save the fisheries, it's already enough for them. So we're always worried about money, because they will talk about money, especially the fishermen. They're like, yeah, so are you going to pay me? And we're like, you're going to fish again? Really? Oh, let me tell you a story. So I used to fish this fish, and they are super excited, So they need to feel like they're part of the process. So that's one way to communicate. Maybe listen more than you talk. That's what I learned. Because I would go as arrogant, you talk too much. And then after 1 year, it's like, okay, you're fine. But then if you're talking to young people, then you need to say, kind of show how cool that is. This is just really cool stuff. And you show nice images and appealing kind of information. So it really depends on who you're talking to, I guess. But doing that bridge between scientific information and this information that's useful to people, it's really hard for me. I think it's really hard, and I'm learning, and I love learning this. It's really cool. and I'm learning with you too. So that was a really cool talk.
So I come from a different perspective because I'm national government, so I tend to go top down. And one initiative that I think could help us achieve this very local connection is that Peru approved its climate change law a few years ago, and within that law, there's something I think that's unique that's been created, which is the Indigenous Climate Platform. That's kind of what it's called. And one of its functions, which was recently approved last year, is to manage traditional knowledge. So it's going to, I mean, this Indigenous platform is integrated by associations of the indigenous communities in Peru, in the Amazon region particularly, and has the Ministry of Environment as its technical secretary. So we're trying, because I mean, it's just starting work to work. So we're trying to see how we can participate, providing this scientific knowledge to complement what they are already supposed to be producing now. That is this traditional or local knowledge. So I think that would be a very interesting experiment to see how we can connect those two. And because it's obviously, as Mel was saying also, you need to listen to what they'll know already and how they're seeing things. And then we can maybe figure out how to connect with our own information for their needs.
We have time for one more question.
Yes, ma'am. Yeah, Felipe Arosvera with Ohio University. So the way I like to put qualitative and quantitative research is qualitative research help us generate those hypotheses that then later on with quantitative research we can test. That's how I enjoy looking at the complementation between the two of them. My question is about data. This was a question that I also had for the previous panel, because there was a comment from one of the panelists saying there's not enough research on this particular field, which all of us who are passionate about what we do, we can say the same about all our fields. Now, my question about data is, what is your take on, making data available for the public, right? Almost open source, so that people from different fields can take a look at your data, conduct statistical analysis, and maybe apply models and methods that are from different fields and categories to your specific data. And I understand, because I do work with classified data, some things that I cannot share. But what is your take on just making as much as possible the data you have available to the public?
I think you should go, data person.
Well, actually, in my case, we don't have much actually data that we produce, except for the model output that we're just starting. So that will be placed on the website and for everybody to download or just look at. But in more generally speaking, I mean, I agree that it's very important to have particularly as a government institute, that if we're producing information, we should put it out. So not just the users, but the scientific community, academic community can use that to produce more science. That is something that at least in the Peruvian government science institutes has not been so much of a common practice. So data tends to be kept not necessarily in secret, but not shared. So it's pretty much as inexistent for the rest of the world. So it is important, particularly data that could be very valuable, because it could be applied in many different ways to be not just put out, but also at least, I mean, how do you say, cleaned up, organized, quality controlled, and put out in a way that people can actually use it. My own impulse would be just to put out the data file directly on the website and say people can download it and use it as they wish. But I mean, if we're providing a service as the government, we should make some effort as well to make it better, the data better, and that takes time. So there's those two aspects that I'm still kind of conflicted about.
Can I add something? Because qualitative data is very different. It is protected in some ways, but I think people's stories and what people say can be taken out of context and then used to harm them. So you have to be really careful when you're doing qualitative research. At least that's my belief, is I have a responsibility to those communities and not create harm. So I need to be careful with how that data is shared. I think in qualitative research, it's very rare to see like the raw data being put out there, like the interview transcripts, for example, because of those things. So it becomes a little bit more challenging. But then the story of like, well, you know, publish more. You mean the paper that's behind a paywall that people can't access? So like, I think we have to get creative with how we share, at least that's a qualitative researcher, getting creative with how that data is shared. Maybe like, I don't know, story maps or like some type of more accessible ways to tell, like storytelling opportunities. So you share the information. But I personally would never feel comfortable just sharing people's interviews out there, because there are things that could be taken out of context, and it has happened. And I'm really cautious that I don't want to create harm for the communities that are giving me so much of their time for free. And then I'm like, I'm going to just share everything you said with me. I'll remove your name though. It still doesn't matter. Like, it could still be misused. So when it comes to qualitative research, I think you have to, there's a lot more nuances in place. You have to be a bit more careful than just numbers. It could probably still be misused, but it won't directly harm a person, I don't think. Maybe it still could. You could tell me later.
So I work with a lot of oceanographic data, so it's a bit easier because in theory it's all freely available anyway. And the biggest problem there is, especially for scientists, is that, and also for everyone else, is that there's too much data, and there are many ways you can interpret and process that data set. And, you know, so what we try to do is to process that data to make it become some useful information. And that's kind of the idea of this Brazilian network of oceanographic data. We're building an online platform of satellite data and buoy data of the oceans all over the coast that will include data that are provided by NOAA and NASA, but also data that we are processing, like harmful algal blooms in Brazil, marine heat waves, this kind of things. So we also did a platform for fisheries. And again, the data were there. A lot of people want to know about the history of fisheries, but data were in reports, and you had to transcript all the numbers to the computer to analyze. So we just did it. Took a student to do it, and she did a great job. Put it on a platform, and you can download plots, can download maps, but you can also download raw data, time series of data. So I think that kind of processing effort really helps from us as scientists to make it available in different forms for different people and make it freely available. So that's how I think we can help.
Well, let's give a big round of applause again to all of our speakers. Thank you. And we can continue these conversations over coffee. Enjoy.
Okay, thank you so much. This was a really interesting session. Now we're going for a break at Plaza, which is around the corner, and then we must be back at 3:15, please, for our next session.
Maria was like hurting. I'm so out of shape. I was almost dying. Well, thank you for
good presentation.
Yeah.
Way to depress everyone. Everyone steered away from.
Explora más contenidos de tu interés. No olvides suscribirte a nuestro canal.